Okay, the last two graphs we need to look at are the tangent graph and the cotangent graph. As with other graphs, we will later see that you can have phase shifts and vertical shifts and things like that. But today I just want to look at the basic graph. So this is a basic tangent graph. This is going to be a basic cotangent graph. If you notice, this function is a rational function, meaning it's divided by something with the x in it, meaning that if that denominator ever equals 0, if we ever put something in for x that make it equal 0, we will get a vertical asymptote. So this graph, like the secant and cosecant graph, has the vertical asymptotes, as does the cotangent. So these all have vertical asymptotes. Now, the only two graphs that have an amplitude are the sine and the cosine. So secant and cosecant didn't have an amplitude. That's a value by which the graph rises and falls below. So like sine and cosine, they rise up to 1, they run down to -1, they bounce back and forth between that 1. These other graphs don't do that, okay? They don't have an amplitude, so to speak. So, and this is a difference with the tangent and the cotangent. Their period is not 2 pi. So sine and cosine, the period of those is 2 pi all the way around the circle. Secant and cosecant are based off of sine and cosine, so their period is also 2 pi. Tangent and cotangent, you only have to go halfway around the circle to start to repeat the pattern. So their period's only pi, halfway around. So this is the difference. The period for both of these curves is pi. Okay. Now, in general, we will find spacing. So I'm going to do the spacing. The spacing is always the period divided by 4. That's the same no matter what you're graphing. Period divided by 4. So the period divided by 4 in this case is going to be pi divided by 4. This is the spacing I'm going to use. Okay. So I'm going to go in here. Tangent, they don't like to start at 0. They like to start at -pi/2. So you can start at -pi/2, or you can just start at 0 and make sure you carry it out to an extra couple of digits. I guess I'll just start at -pi/2 so we can see that. If I start at -pi/2, and then my spacing is pi/4, another pi/4 would land me at -pi/4. And then if I went, so let's just see a circle. Let's just see our unit circle so we can see what's happening. This is -pi/2, right? Go this way, -pi/2. And then if I add pi/4, I'll land here at -pi/4. And then if I add a pi/4, I'll land at 0. And then if I add a pi/4, I'll land at pi/4. And then if I add a pi/4, I'll add pi/2. So this is the only one you kind of got to do this way. So we start at a different place, just because it helps us see the whole values. This is going to be 0, this is going to be pi/4, and this is going to be pi/2. So since this is the first time we're graphing this, we're going to do the point plotting, and then from that point forward, we'll kind of just recognize the pattern of tangent. So tangent is formed by sine of x over cosine of x. So what I'm going to do is go through and write out the xy coordinates for those angle values. And I know how to do that because of the unit circle or reference triangles. So I know at -pi/2, this is the point this is the point 0, x is 0, and y is -1. So what I know here is cosine is 0, sine is -1. At this point, -pi/4, that's the same thing as 7pi/4. And so its coordinates are 1 over the square root of 2, -1 over the square root of 2, because I'm in quadrant 4. Right, positive, down, negative. This point 0 has the coordinates 1, 0. This point pi/4 has the coordinates 1 over the square root of 2, 1 over the square root of 2. Both of those are positive because quadrant 1. This point here, pi/2, has 0, 1. So the cosine of any of these angles is the x coordinate, and the sine of those angles is the y coordinate. So let's use that information to figure out what the tangent of -pi/2 is. The tangent of -pi/2 is the sine, -1, divided by 0. And we are not allowed to divide by 0. So what that tells me is this is undefined. That's what that tells me. So what that tells me is vertical asymptote right there. That's what that tells me. Negative pi over 4. It is going to be the sine, negative 1 over the square root of 2, divided by the cosine, 1 over the square root of 2. These are the same value, so it's going to give me a 1, but it's a negative divided by a positive, so this is going to be negative 1. At 0, it's the sine, 0, divided by the cosine, 1, which is the value 0. It's equal to 0. This is not dividing by 0. This is just equal to 0. 1 goes into 0, 0 times. Pi over 4, 1 over the square root of 2 divided by 1 over the square root of 2 is going to give me a positive 1. And then pi over 2, sine 1 divided by 0 is undefined again. Undefined again. That's what I get. So this is my tangent graph. I'm going to divide up I'm going to start at negative pi over 2, and I'll probably go out another unit. So let's see, this will be negative pi over 4, negative pi over 2. Negative pi over 2, negative pi over 4. This is 0. This is pi over 4. And this is pi over 2. So this is pi units. That's 1 period. So what happens here? Oh, it's undefined. This is a vertical asymptote at negative pi over 2. At negative pi over 4, it's got a value of negative 1. So it's down here, negative 1, wait, that's it, negative 1, 1. That's what it's supposed to be. I put that too low. Right. And then at 0, it's at 0, 0. And then at pi over 4, I'm up here at 1. So this is 1 and this is negative 1. I'm up here at 1. And then at pi over 2, it's also undefined. So this goes like this. Okay, so now how do I connect the dots? I connect them like this. Since these are vertical asymptotes, my curve will hug it. So down here, it's going to be hugging this vertical asymptote, and then it's going to come snake through here and go up here. This is one cycle, one period of a tangent graph. And so then it will repeat. So let's just carry it out another pi. So let's just keep my units. So plus another pi over 4 would be 3 pi over 4. Plus another pi over 4 would land me at pi. Plus another pi over 4 would be 5 pi over 4. Plus another pi over 4 would be 6 pi over 4 or 3 pi over 2. I don't have to plug those values in, although I could if I wanted to make sure, but I can just repeat the pattern. See, it sort of looks like x cubed. It's sort of, tangent sort of looks like x cubed. Like that. Okay, that is terrible. Like that. That still looks terrible. Let me try this one. Oh, it's getting worse. I don't know what to say. It sort of looks like that. Okay, so asymptote, and then it goes low, middle, high, asymptote. So it's going to go like this. That's going to be this is a typical tangent curve. Okay, now let's do cotangent. What will he look like? All right, well, he's defined to be cosine over sine. Tangent is the only graph that you kind of start in a different place. We can start at 0 for him, so let's do that. What we know, okay, how would you begin this? You go, oh, what is the period? The period is pi, because tangent, cotangent are only pi. All right. So then you would take the period and you would divide it by 4. Okay, take the period, divide it by 4, and figure out your spacing, pi over 4. Okay. Because this is the first time, I'm going to do the point plotting like I did here. Later on, we'll just lay out the points because we're used to it. But right now, we'll say, okay, 0, then pi over 4, then pi over 2, then 3 pi over 4, then pi. This will give me one cycle of the cotangent, which is defined to be the cosine of x over the sine of x. Okay, let's go here. So, it starts at angle 0. At 0, cosine is the x value, sine is the y value, so it's going to be 1 over 0, which is undefined. Okay? Pi over 4. Cosine divided by sine, same thing, divided by same thing, we get the number 1. Pi over 2, cosine divided by sine, we get 0 divided by 1, which is just the number 0. 3 pi over 4. Oh, let's draw that. 3 pi over 4 is here. What are his coordinates? This is negative x, negative 1 over the square root of 2, positive y, 1 over the square root of 2. And then pi. What are his coordinates? Negative 1, 0. All right. So cosine over sine would be negative 1 over the square root of 2 divided by 1 over the square root of 2. Same thing over same thing will give me a 1, but it's negative over a positive, I get a negative 1. All right, pi cosine over sine would be negative 1 divided by 0. We get another undefined right there. All right, we're about to graph this guy. The undefined places are telling me that that is where, oops, I want this to be over here. That is where my asymptotes are. So this is what a cotangent looks like. At 0, it's undefined, meaning I've got an asymptote. Okay. This is 0, so let's say pi over 4, pi over 2, 3 pi over 4, pi. At pi, I've got another asymptote. And if I wanted to carry it out, let's go again. So this will be pi over 4, pi over 2, 3 pi over 4, pi. Then we go 5 pi over 4, 6 pi over 4, which is really 3 pi over 2, 7 pi over 4, and then 2 pi. So remember, like with sine and cosine, it took all the way to 2 pi to get one cycle, but we'll get 2 cycles with tangent because it only has to take pi units to repeat. So this is how this looks. We have an asymptote, and then at pi over 4, it was 1. So here's my x-axis. This is 1. This is negative 1. It starts at, so here it's at 1. And then at pi over 2, the y value is 0. And then at 3 pi over 4, my y value is negative 1. And then I hit my asymptote. So this is what a cotangent graph looks like. It hugs the asymptote, then it snakes through here, and it goes like this. Looks a lot like a tangent graph, only flipped, right? It's reflected. So it's this, only flip-flopped. Let's go another cycle. Asymptote, then it's going to go high, middle, low, asymptote. Once you see the pattern, you do not have to calculate every time. However, if you want to make sure you're doing it right, you absolutely can plug in the x values and see that you get those y values. So that is a look at all 6 graphs. If we wanted to talk about the domain and range for these guys, let's do cotangent because that's what I have a blue marker. X is not allowed to be anywhere the sign is equal to 0. Well, where is the sign equal to 0? We are hitting that at the sign equals to 0 at 0 and pi and 2 pi and 3 pi and 4 pi and 6 pi and 5 pi, any pi. So where x is not allowed to equal to n pi, where n is an integer. So that's the domain for cotangent. And then the range, what can we get out for our range? Any real number. As low as we want to go, high as we want to go. Negative infinity to infinity. All right, real quick, the tangent, let's talk about his domain. Where is it not okay for him to equal 0? It's not okay for him to equal 0 wherever the cosine is going to be 0. The cosine, the x value will be 0 at pi over 2, negative pi over 2, 3 pi over 2, and so on, the pi over 2s. So we have to say the domain here, x cannot equal to 2n plus 1 is how you create an odd number times pi over 2. This is where it gives us trouble. And then we would say the range is all real numbers, as low as we want to go to as high as we want to go, and that's the range. So that's a look at the 6 trig functions, just their basic graphs without any kind of crazy shifting or stretching going on. We'll look at that, I think, after you've gotten through test 1.